All right, in lesson 11.6, we're going to add and subtract rational expressions. And this is the lesson you should be thanking those 5th and 6th grade teachers that taught you how to work with fractions. So just like when we have a normal fraction, we add the numerators and the denominators. If they're the same, we just carry them over. We don't have to do anything with them. So you'll notice we have our, in the numerator, 1 minus x plus our 3x minus 3 from the second fraction. And we only wrote the denominator one time. Then, since it's all addition, we went ahead and combined our like terms and got 2x minus 2. And then we noticed that we could factor. From the numerator, we could take out a 2. And then for the denominator, if you remember, we would say 2 times 5 is 10. I don't know why I put a minus sign there. And then we bring down the 2x squared. We bring down the 5. We need something that multiplies to 10 and adds to negative 7. And that's going to be negative 2 and negative 5. Then we're going to factor by grouping. So I'm going to place parentheses, put a plus sign in between, factor out a 2x, so we have x minus 1, factor out a negative 5, x minus 1. So we end up with our leftovers, 2x minus 5, and our lookalikes, x minus 1. So the denominator factors out to 2x minus 5, x minus 1. We're able to reduce, and we end up with 2 over 2x minus 5. And I'll keep reminding you, pause and rewind whenever you get a little bit stuck or you want to try something on your own. All right. This next slide has a lot of directions, but basically it's just repeating what you kind of already know about fractions when they have unlike denominators. So I'm going to just work with a normal fraction. If I had something like 5 over 24 plus 7 over 72, and we want to find a common denominator. So it says we're going to factor the denominators, and I'm just going to factor the 72 because I know 72 comes out to 24 times 3. So then we can see that the first fraction is missing the times 3 part. So I'm going to multiply the numerator and the denominator by 3. And that's going to create common denominators. And 3 over 3 is the same as 1. So even if I had a rational expression and I'm multiplying by x plus 1 over x plus 1, it's still equal to 1. So it's changing what it looks like, but you're really using our identity property. All right, so these are the steps. Maybe you write those down, and we're going to try one. Okay, so I'm looking at this guy, and I can see the first denominator is already simplified. So now I'm going to look at the second denominator. We're going to factor it. What multiplies to negative 18 and adds to 3. And we wrote it off to the side, and so we see that the first fraction is missing the x plus 6. So we're going to end up multiplying the first fraction by x plus 6 over x plus 6. Now I can't just add everything together like I did in a previous example because we have multiplication happening here. So I'm going to have to distribute the 2 to the x and the 6, and then I'm going to combine my like terms. So we have our 2x plus 12, and then we had this x over off here. So I'm going to go ahead and combine it. And then we're looking at it, and we say, oh, I can take out a 3. So we're going to factor out a 3. And then unfortunately, we factored, but we weren't able to reduce anything. So that's our final answer. And the one thing I want to point out is to keep everything, once we factor it, keep it in factored form. Keep it all in factored form, because that makes sense, because as we continue with the problem, we might be able to reduce it. So there's no use multiplying it all back together. In this instance, our denominators have nothing in common. So there's a shortcut, but before I show you the shortcut, I'm going to do it the long way. Let's see, so we would multiply this side by 3x minus 1 over 3x minus 1. We're going to multiply this side by x plus 1 over x plus 1. So I'm going to put these all in parentheses to make it clear. Now we have to FOIL the numerators, FOIL the denominators, and remember we have this plus sign. So when I FOIL the numerator, I'm going to get x squared plus 9x plus 8, then plus this guy. Then we end up with 3x squared plus 8x minus 3 by FOILing those two binomials, all over 3x minus 1 and x plus 1. We only write the denominator one time. Then we're going to combine our like terms. So we end up with 4x squared, and then we have a positive 9x and an 8x, so 17x, and then we have an 8 and a negative 3, so plus 5, all over 3x minus 1, x plus 1. We could try to factor that numerator, but I know I use the discriminant, or b squared minus 4ac. And when I put that numerator into this expression, I did not come out with a perfect square, so I know the numerator is not factorable. Now I'm going to show you the shortcut. Now this works because we have totally different denominators. So basically we can multiply across, multiply the x plus 1 with the x plus 8, and then if we multiply the denominators together, we're going to see we get the same exact expression that we had when we did it the other way. So remember we foiled, here's that plus sign in the middle, and we wrote the denominator one time. Combine our like terms, and there's our final answer. The same exact thing we got by doing it the other way. I tend to like to use the first method, but you're welcome to use this little bit of a shortcut. Okay, so we'll practice some problems when I see you in class.